Imagine solving jigsaw puzzle but with lots of missing pieces. It is so confusing. Similarly in business, missing data hinders our ability to identify trends or pattern, making it harder to take calculated risks for potential big rewards. In today's video, we'll discuss what central tendencies are and how they are used to solve missing data to reveal clear trends using a Kaggle dataset. Stick around for a bonus tip on enhancing insights with effective data visualization. But first, let's explore why missing data happens. Missing data can happen for various reasons, such as missing completely at random, missing at random, and missing not at random. We should understand each of these before fixing missing data to make reliable conclusion and trend. Missing completely at random means that the missing data occurs purely random, without being influenced by any other variables in the dataset, such as age or gender. For example, imagine you're filling out a long survey and, suddenly feeling tired or distracted, you accidentally skip a question. It wasn't intentional, it was just a random mistake. The key point is that the missing data does not affect the overall picture of the dataset because it's completely random. Thus, it should not be a problem. Consequently, relying on the remaining complete data by simply removing missing value is still acceptable for understanding general trends in the data. Missing at random occurs when the likelihood of missing data is related to other observed factors. For example, if people in lower income groups are less likely to answer a survey question, the missing data can be explained by the income level of the remaining respondents. In other words, we can use information from the non-missing data to impute the missing values. The missing values are predictable because we're not completely in the dark about what might be causing the missingness. One solution to handle this missing data is through imputation methods, such as using central tendency measures like mean, median, or mode, which I will explain later. Missing not at random, now this one is the trickiest. It happens when people intentionally withhold information. For example, imagine wealthy individuals with an annual income more than $200,000 who don't want to disclose their earnings in a survey to avoid any tax issues. In other words, their income data is deliberately missing. In this case, the missing data isn't random, and it is influenced by an internal factor, like the high income itself. This type of missing data is tough to fix because we don't have enough information to accurately guess what the missing values should be. One way to tackle this is by doing a resurveying strategy, basically going back to the people who didn't respond. But here's the downside: this approach can be really time-consuming and resource-intensive. Before continuing, if you found this video useful, don't forget to subscribe to my channel so you won't miss future data literacy tutorials and tips on how to apply data science and analytics in real business settings. Besides, feel free to comment on the box below for any questions you may have and I would be happy to answer. Okay, let's continue. Now that we understand possible reasons of missing data, let's move on to discussing solutions using central tendency measures. Central tendency measures are statistical tools to identify the center, or average of a data distribution which consists of mean, median, and mode. Mean or average is the sum of all values in the dataset divided by the number of values, while median is the middle value when the numerical records are arranged in ascending order. If the number of records is odd, the median is the middle value. If they are even, the median is the average of the two middle values. On the other hand, the mode represents the most frequently occurring value in the dataset. Unlike the mean and median, which are valid for numerical data only, the mode can be applied to both numerical and categorical data. With these measures, which one is applicable to impute missing value for numerical and categorical data? To answer this, let's understand the basic of skewness. Skewness is a statistical term that tells us about the shape and direction of a data distribution, especially how it deviates from a normal or bell-shaped curve. In simpler terms, skewness helps us understand whether the data is leaning more to the left or the right. There are three main types of skewness, such as left-skewed, right-skewed, and zero-skewed. Regardless these three main types, there will always be one peak or the highest point in the distribution, and this point is known as the mode, the most frequent value in the dataset. In a negatively skewed distribution or left skew, the tail stretches left, pulling the mean lower than the mode and median due to a few extreme low values. while in a positively skewed distribution or right skew, the tail stretches right, pulling the mean higher because of a few extreme high values. From this comparison, the median is less affected by skewness, making it a more reliable measure of central tendency or imputation for skewed data, such as income reports, where it is often preferred over the mean. Skewed distributions are typically caused by rare events or anomalies, which are common in real life. For example, when collecting income data, most people earn normal income amount, while a few individuals earn much higher amounts. These rare, high income values create a skewed distribution, where the mean is much different than the median. Now, in a zero skew situation, which means the data distribution is symmetrical, the left and right tails are balanced with minimal distortion. This creates a bell-shaped curve, like the normal distribution we often talk about. In this case, the mean, median, and mode will all be very close to each other. Therefore, when the data is symmetric, we can safely use the mean, or average, as a good measure of central tendency. The next question is, when should we use the mode? The mode is most useful for categorical or discrete data, rather than continuous data. For example, if you're dealing with missing values in a dataset that includes things like favorite product categories, the mode, which is the most frequent value, is a great choice to fill in those gaps. This works well regardless of whether the data is skewed or not. In this case, the missing value for favorite product can be filled by t-shirt.
Now, let's use these central tendency concepts to Titanic dataset from Kaggle to find patterns or trends of passenger survival rates across different age group and embarkation port.
Before diving into the Titanic dataset, it's super important to start with a data quality assessment. This gives us a clear overview of the entire dataset, setting the stage for our analysis. We've got 891 passenger records, and guess what? The survival rate is around 38%. Now, let's talk about the variables. We've got two types, categorical ones, from passenger class to embarkation port, and numerical ones, from age to fair amount. So, what can we do with all this? We'll focus on tackling missing values for age and embarkation port because these missing data are not that significant compared to cabin variable. As for the cabin variable, it's a bit of a challenge since over 50% of the data is missing. In fact, it's as high as 77%. That's a huge chunk, so we'll steer clear of it to avoid introducing any bias. Let's dive into filling those missing values for age and embarkation port. First, we'll draw some histograms to visualize the distributions of these variables. We're filtering out the missing ones to keep it clean. As we can see, the age distribution is right skewed, with the mean sitting at 30 years, the median at 28 years, and the mode hanging out between 18 to 23 years old. Since it's right skewed, the median value of 28 is our go-to for filling those missing ages. Pretty straightforward, right? Next, let's talk embarkation port. We'll use the mode to find the most frequent value, and guess what? Southampton takes the crown. So, we'll fill the missing embarkation port values with Southampton. With these missing values filled, we're all set to move forward and start uncovering some exciting trend from this Titanic dataset. When we examine the survival rates by age, the highest survival rate occurred for passengers under 18, especially female passengers, and it makes sense, right? The Titanic's lifeboat protocols prioritized women and children first during the tragedy, and everyone knows from the movie. But hold on! Introducing the embarkation port reveals a fascinating twist. Passengers from Cherbourg consistently had higher survival rates regardless passenger age. Why is that? Here's my bonus point on effective data visualization. To answer why passengers from Cherbourg had higher survival rates, we hypothesized that many were first class, with better access to lifeboats. To prove this, we'll use a 100% stacked bar chart when dealing with categorical variable where the chart shows the percentage of passengers by class at each embarkation port, instead of the number of passengers. The bar chart reveals that 51% of Cherbourg passengers were first class, while Queenstown and Southampton had mostly third-class passengers. The key takeaway? Future sea transportation must ensure equal lifeboat access for all passenger classes.
So that's exactly how central tendency measures help clarify data pattern or trend, as trend is indeed our friend. But simply looking at trend is not enough because we need to grasp data distribution instantly via robust statistics such as an interquartile range. Click here on this video if you want to learn how robust statistics data analysis helps business decision making. Thanks for watching my video.